So here's the induced fit model, a little picture of that. You can see obviously we've got our enzyme here. Substrate doesn't quite fit, but the active site will actually mold around and change shape. Then you have your enzyme product complex, and leaving the enzyme is our products. So a few words here that we can see at the bottom. We're going to have a little chat through those. So what do enzymes do? They actually take an alternative reaction pathway. So normally what happens in a chemical reaction, you have a substrate and that gets converted to a product. Okay, sometimes that is reversible and products can get converted back into the substrate. Obviously there may be more than one substrates, more than one product, but it doesn't matter. In an enzyme catalyzed reaction, what happens is that the substrate will actually bind to the enzyme. So you get your enzyme and you bind to the substrate. And what that forms is what's called an enzyme substrate complex. Enzyme substrate complex. And that will crop up time and time again in the exam. It's always a marking point. It's to do with enzymes, to do with anything protein, enzyme related. That they'll try and get that in, so that'll be a marking point somewhere. So an enzyme substrate complex. Okay, so what happens then is that will then form our enzyme product complex. Okay, so that's down here, enzyme product complex. Before our products are then obviously expelled, and we have still our enzyme and still our product. Remember, enzyme is not used up in the reaction. Okay. So how does this actually mean that the reaction is quicker? How does it take place quicker? And what it does is it lowers the activation energy. So the activation energy, which is the energy needed in order for this reaction to happen. And as it says quite clearly here, what the enzyme does is it lowers the activation energy. Okay. You usually see a graph. Okay, you've got your graph here, and that's time, and over here we have the energy of the molecules. So a normal reaction, what would happen is you'd heat it up, okay, and you would get, so your substrate would be here, you'd then have your products down here, basically this here is your activation energy. Okay, so that is the energy you need basically to put in order to get your products. So what does an enzyme do? So essentially, an enzyme will lower this activation energy. So if we try and go for a different color here, let's go for red, all that will happen is you'll need to put in less activation energy in order to, again, substrate products, in order to get your products. Okay, and it'll take less time as well. Before you can change it into a product, you've obviously got to overcome this, what's called an energy barrier, and that's your activation energy. The slower the reaction, the less energy that is in that reaction. Okay, so most reactions have large activation energies, so they don't happen on this sort of useful time scale. So in order to make this these timescales shorter, you have to add enzymes into reactions. This is done commercially. This is done naturally as well in your body. So next video, what we're going to do is we're going to look at factors that will actually affect an enzyme reaction. Again, it doesn't change much from GCSE. You've got pH and temperature. So I'll have a look at that in the next video. Be sure to make sure you watch not only this, but the other videos that have been put up on the wiki spaces. There's some animations on there. There's some different sort of takes on this. Maybe a little bit more interesting than just me talking through it. So make sure you do watch those as well.